Hey kiddos, today we're doing Unit 6, Lesson 4, and this is all applications of just simply finding zeros, okay? So our goal for every different one of our application parts will be to find the value of x. So the first thing for area models that we always need to do is set the equation equal to the area that they give you. So let's do this with number 1. Find the dimensions below if the area is 128 square feet. Well, area is length times width. So I'm going to have 128 equals x plus 1, x minus 1, x plus 7. All right, let me zoom in a little bit. Next, I'm going to multiply out our binomials, okay, and then set the equation equal to 0. So let's do this. X times x is x squared, x times 7, and negative 1 times x. If I simplify, I'll get 6x. Negative 1 times 7 is negative 7. And that still equals 128. So what I need to do is subtract the 128 so that it now equals 0. So now I have 0 equals x squared plus 6x minus 135. Okay, now I am ready to factor this out. So let me just put my x puzzle kind of out of the way over here. Negative 135 and 6. So if I do 15 times 9, I will get to 135. 15 times 9. But I need to subtract the 9 to combine them to get this positive 6, okay? So here are my factors. 0 equals x minus 9 and x plus 15. And so we've done step 3. We factored it. Step 4, use the zero product property to solve for x. So I'm just going to shortcut this and say x equals 9 or x equals negative 15. And finally, step 5, use only the positive value of x to answer the question. Why only the positive value? Because we are talking about dimensions of a figure. And so if I was measuring a yard, my yard, let's say it's 3 feet by 5 feet, I couldn't ever have a negative 3 feet part of a yard. It always has to be the positive value, okay? So we're going to stick with the positive. So here I've got 9 plus 7, which gives me 16. And then here I have 9 minus 1, which gives me 8. So my dimensions are 8 by 16. Okay, so that is how I answer and solve an area problem. Let's do the second one where we need to kind of set it up. They don't give me a picture. The length of a rectangle is 6 meters less than its width. If you want to draw out a picture, you can. So I know the width, and the length is going to be whatever the width is minus 6, because it's 6 meters less than. So now I'm ready to set up my problem. It tells me that the area is 27 square meters. So let's do our width and our length multiplied together equals the area. Now we're ready to multiply this out. W squared minus 6W. And then I'm going to subtract the 27 so I can set this equal to 0. And now I'm ready to factor this. So if you want to do your X puzzle, 27 and 6. I'm thinking 9 times 3, but the 9 needs to be negative to get to this negative 6. So here are my factors. W minus 9, W plus 3, and of course they still equal 0. So those are my factors. Now let's use the zero product property. W equals 9 or W equals negative 3. And again, we want to only keep the positive value. Okay, so if we're going to find our dimensions, well, W equals 9. So W minus 6 is 9 minus 6, which is 3. So my dimensions are 9 by 3. And I'm finished. Alrighty. Let's look at our last one, dealing with area. So the area of the shaded region is 59 square units. What are the dimensions of the outside of the rectangle? So the first thing that we need to do is use that first sentence to solve for x, okay? The area of the shaded region. So what I'm going to do is I'm going to find the area of the entire outside rectangle. So x plus 6 times 2x minus 1. That is the outside. But then they took away this chunk in the middle. So I need to subtract out the area of that white part. So I'm going to subtract this out, and that is x times x plus 3. So the large rectangle minus the area of the small rectangle should equal 59. Okay, so I need to subtract them out. So let's go ahead and just multiply everything all out. Okay, so this will give me 2x squared minus x plus 12x minus 6. Now let's do the next one. Negative x times x is negative x squared. And then negative x times 3 is negative 3x. And I'm going to go ahead and subtract over my 59. And so now all of that hot mess equals 0. I just need to combine my like terms. So my x squares and my x squares are right here. And that is going to give me, okay, what goes there? Second, I will combine all of my x's. And 3x, and that's going to go there. And lastly, I will combine just my constant terms. So this is a negative 6 and a negative 59. And that will go there. Okay, so 2x minus 1x is 1x squared. 12x minus 1 is 11. 11 minus 3 is going to give me positive 8x. And then negative 6 and negative 59 is going to give me a negative 65. Okay, now I'm ready to do the factoring step. So if I have negative 65 up here and a positive 8 down here, I think 5 times 13, but the 13 has to be positive to get to the 8. Okay, so I've got my factors. X minus 5, x plus 13. Let's apply the zero product property. And of course, we're only going to keep the positive value of x. Okay, so I have found the value of x. Now here's what I need to do. I need to find the dimensions of the outside of the rectangle. So just the outside is going to be this x plus 6 and this 2x minus 1. So let's go ahead and fill these in. So x equals 5. So I get 5 plus 6 is 11. And then again, x equals 5. So 2 times 5 is 10, minus 1 is 9. So the dimensions of the outside of the rectangle are 9 by 11. If for some reason you wanted to double check in any way that the area of only the shaded region does come out to 59, we could also find the area of the little rectangle using the value of x equals 5. So this would be 5 times 8, which is 40. What is 99 minus 40? And it does come out to equal that 59 square units, okay? Alrighty, so we are all done with our area problems for today. Let's take a look at consecutive integers, which you did learn about briefly in Math 1. All right, so some notes here. First of all, what are consecutive integers? They are numbers that are in order. Okay, so this could be negative 7, negative 8, and negative 9, although I should reverse their order since I switched them to negative. But and they're 3 numbers that are hanging out in order. If I'm going to write that using variables, it would be x, x plus 1, and x plus 2. So think about if your very first number that you have is the number 8. How would you get from 8 to 9? You would have to add 1. Okay, how would you get from 8 to 10? You'd have to add 2. So this is how it works out when we just have consecutive. What about if we have consecutive even or consecutive odd? These really don't matter how you set them up, because odds are 2 digits apart and evens are always 2 digits apart as well. So we use the same variables for both odds and evens, x, x plus 2, and x plus 4. The thing that we're going to need to pay attention to is, remember, in the area models, we always threw away the negative value. Well, now sometimes they might want us to find consecutive even integers that are negative, okay, or odd integers that are negative. So we're going to have to pay attention to even and odd to know, or I'm sorry, negative and positive to see which value of x we should keep in the end. So let's just jump right into example 4. So we're going to have to translate this. The product of 2 positive consecutive even integers is 80. So 2 consecutive even integers. So since I'm only using 2 integers, I'm going to do x and x plus 2. And the product of 2 positive consecutive even integers is 80. So I'm already looking at this, guys, and I'm thinking 8 times 10 is 80. And they're 2 apart, and they're both even numbers. So I could sometimes logically come to the conclusion without having to solve this via factoring, but I still want us to walk through the process so that you can see how to do it, okay? So I'm going to multiply this out, x times x, x times 2, and then I'm going to subtract over this 80 so that it's set equal to 0. Now I'm ready to do step 3, which is to factor. So negative 80 and 2, so yeah, 10 and 8, that 2 is positive, so the 8 has to be the negative one. So my factors are x plus 10, x minus 8. Step 4, I'm going to use the zero product property. So x equals 8, x equals negative 10. All right, and now we're ready to answer the final question using the correct positive or negative value of x. So in this situation, they wanted positive. They wanted me to find a positive value. So which of these numbers is positive? And it is the 8. Okay, so my two consecutive even integers are 10 and 8. Great job. Let's do number 5. This says find 3 negative consecutive integers such that the product of the second and third integer is 132. In your notes, I had typed a different number here. If you would please fix that to reflect 132. Okay, so find 3 negative consecutive integers. Consecutive is over here. So I need 3 numbers. So x, x plus 1, and x plus 2. Those are my 3 unknown numbers. Now to set this up, they say the product of the second and third integers. So that's these two. So x plus 1 times x plus 2 should equal 132. Okay, so let's go ahead and multiply this all out. So I'm going to have x squared plus 2x plus x plus 2, and I'm going to subtract my 130 so that it equals 0. Next, I'm going to combine my like terms. So this will give me 3x, and it's positive. This is going to give me negative 130. Okay, let's do my factoring. Negative 130 and 3. So I came up with 10 times 13. 10 times 13. And so they've got to combine to give me a positive 3. So let's do the negative 10 here. Okay. All right. So now I'm going to put these in their factors. X minus 10 and x plus 13. And now we're ready for the zero product property. So I get x equals 10, x equals negative 13. Okay, so now I'm ready to decide. So negative integers right here. So I'm going to keep the negative. So I'm going to have negative 13, negative 12, and negative 11. And if you want to double check the answer here, negative 12 times negative 11 does equal 132. Okay, so these are my 3 integers. Alrighty, great job. Let's now move over and we're going to do briefly 3 examples using projectile motion. Now, we've already talked about projectile motion, so I want you just to focus today on the fact that all we're doing today is finding zeros. Okay, that's all that we're doing. So all of these examples are only asking us for zeros. You can still find the maximum height, the minimum height, how long it takes things to get to certain places. All those other features can still be found out, but our focus is on finding zeros today. So a soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second, and then they give us the equation of the ball. How many seconds will it take for the ball to reach the ground? So what that means is I want my h to equal 0. If the ball is going to hit the ground, the H value is 0. Okay, and so now what we're ready to do is factor this. We're going to factor this. Let me zoom in a little bit. So the first thing that I see is both of my numbers have a t and both of them are even. So I can go ahead and take out a GCF. I'm also going to take out the negative with it because I never want my leading coefficient to be negative. So negative 2t. And then my leftovers will be 8t plus 45. Oh, I took out the negative, so it's going to change this sign. So this should be a negative 45. Okay, now I'm going to use my zero product property. So I'm going to make a chart. So negative 2t equals 0. So if I divide by negative 2, I get the time is 0. Let's look at the other time. 8t minus 45 equals 0. 8t, I'm going to add 45 to both sides, and then divide by 8. And when I do that, I will get 5.625. So I have two zeros here. Which one of these zeros is when the ball hits the ground after it's kicked? Okay, so I've got this situation. This is 0, 0, and this is 0, 5 point. Oh, I'm writing this backwards. 625. Okay, so these are the two ordered pairs. Which one of them would be after the ball is kicked and reaches the ground? Well, here the ball is sitting there, no time has passed, so it hasn't been kicked yet. So when it's kicked, it's back on the ground. That's why the height is 0 again, but now it's been 5.625 seconds. Okay, so 5.625 seconds. And we're back on the ground. Awesome. All right, let's look at 7. When Joey dives off a diving board, the equation of his pathway can be modeled by this equation. So let's think about all the different methods that we know. This has a bx term, so I can't do it by taking square roots. What are our other methods? Completing the square. Well, my a value does not equal 1, and the b value is not an even number, so I can't complete the square. That leaves me with either factoring or the quadratic formula. So let's find the discriminant to see which method is going to be easier for us. So the discriminant, if you remember, is b squared minus 4ac. So I'm going to get 15 squared minus 4 times negative 16 times 12. Okay, 15 squared is 225. If I multiply all of this out, I get a positive 768. And so if I add these two together, I get 993. 993 is not a perfect square. Not a perfect square. So because this is not a perfect square, that tells me that I cannot solve this by factoring. Okay? I cannot solve this by factoring. So I have to use the quadratic formula. All right, so let's go ahead and just fill in the quadratic formula then. Remember, this was A, B, and C. Okay? So x equals negative b plus or minus the square root. Remember, this is the discriminant. So we already have simplified the discriminant. It's 993 under here. All divided by 2 times a. Okay, so I'm going to simplify this again. And I get negative 15 plus or minus 993, the square root of that, divided by negative 32. So I'm going to go ahead, guys, and just type this in my calculator. Okay. So let me open up my calculator. And so if you have this, where's the equation that I'm typing? There it is. Okay, so I'm going to do negative 15 plus the square root of 993 and hit enter. And then I'm going to divide that number by negative 32. And so one of my solutions is negative 0.52. Let's find the positive solution now, okay? So I'm going to clear this out, and I'm going to type this in again. Negative 15, but this time I'm going to use the minus second square root of 993 gives me that. And now I'm going to divide it by negative 32, and I get a positive 1.45. Okay, so find the time that it will take for Joey to reach the water. Well, time can't be negative, so it's got to be 1.45 seconds. So that's how we solve one of these, finding the zeros using the quadratic formula. Now for number 8, I want us to use the Desmos calculator. All right. So at the end of the school year, Rachel and Amber threw their algebra textbooks off the top of a 12-story building. The equation of the pathway of each book is given below. By how many seconds does Rachel's textbook beat Amber's textbook to the ground? So I'm just going to go to Desmos, and I'm going to type this in. Okay, so my red line is Rachel. My red line is Rachel, so let me use my red pen. And I'm going to click on her equation, and I'm going to find out that it took 4.481 seconds for Rachel's book to hit the ground. Now let's look at Amber. Amber's book took 5.09 seconds to hit the ground. So how much faster was Rachel's? So I just jotted down those numbers. So now let's subtract them. 5.09 minus 4.481 minus 4.481 gives me 0.609 seconds. Okay, so we could very easily have solved both of these equations using the quadratic formula and come to that same conclusion. I just kind of wanted to speed this up a little bit and show you that yes, you can still use the Desmos calculator to solve any types of problems like these, okay? So that is everything for today's lesson, guys. It was all application problems of quadratics and finding their roots. Until next time.